Welcome class 8. Today's topic is thermal expansion. We know that every substance is made up of molecules, and these molecules, when they are heated up, when the substance is heated, then the molecules will start vibrating, and when they vibrate they tend to move apart from each other, and thus we see the substance expands. So when the expansion takes place, the volume is increased, and if the substance is cooled down, or in other words, if we take the heat or withdraw the heat from the substance, then again it will contract and the volume will decrease. Thus we can say that any substance, whether it's a gas, liquid or solid, if there is a change in temperature, whether the heat is supplied or the heat is taken, then there will be a change in dimension, either in terms of its length or in terms of its area or in terms of its volume. Different substances expand differently for the same amount of heat. So, how much a substance will expand or contract depends on the coefficient of thermal expansion of the substance. The coefficient of thermal expansion describes how the size of an object changes with a change in temperature. It measures the fractional change in size per degree change in temperature at a constant pressure. So let's understand what this means. Let's say there is an object A, and when it is heated, then it increases its volume to the other to this much. Okay, and let's say there is another object B, and it also increases when supplied by heat, and it increases its volume. So in 1 degree Celsius rise in temperature, if object A is increased this much and object B increases this much, then clearly we can see that B expands more than A. So in this case, we can say that the coefficient of thermal expansion of B is greater than that of A. This means that the coefficient of thermal expansion determines by how much the body is going to expand or contract with every degree rise or fall in temperature. Anomalous expansion of water. Every substance contracts on cooling, and when they contract, the density increases and thus the liquid solidifies to form solids. Even water is cooled. When cooled, it contracts until 4 degrees Celsius. But from 4 degrees Celsius, when it is cooled, instead of contracting, it expands further. This behavior of water is something unusual. That's why we call it as anomalous expansion of water. So its density decreases until it reaches 0 degrees Celsius. From 4 degrees Celsius to 0 degrees Celsius, water expands and thus its density keeps on decreasing. That's the reason the density of ice is less than the density of water. If you check, the density of ice is 0.9167 grams per centimeter cube, whereas density of water is 0.9998 grams per centimeter cube, which is almost equal to 1 gram per centimeter cube. Thus, the density of water is greater than the density of ice, and also the density of water is greatest at 4 degrees Celsius. Because of this reason, ice floats on water and icebergs also floats on sea. Uses of anomalous expansion of water. In cold weather, when water freezes, the aquatic life can still survive because water at 4 degrees Celsius, being the densest, goes down at the bottom, and ice with less density freezes only at the top surface. In this way, the aquatic life can survive since 0 degrees Celsius ice floats on the topmost surface, and below that the water is in the liquid form and the aquatic life can survive. So with this we come to an end of the video for today's lesson. If there's any doubt, please let me know through your mails. Thank you.